Stop what you're doing and point straight down. Go ahead, do it. Now imagine someone standing on the exact opposite side of the planet doing the exact same thing, pointing in the completely opposite direction, calling it the same word, down. That's when you realize something disturbing. The direction you're pointing doesn't actually exist. It's an illusion created by gravity and your perspective. And what scientists have just discovered lurking above and below our solar system prove that every boundary we thought we understood, every map we drew, every assumption we made about where our cosmic neighborhood ends was catastrophically wrong. For generations, we've been taught a comforting lie. The solar system is a flat disk, 8 planets orbiting in a neat plane called the ecliptic. Above that plane, nothing. Below it, empty void. Just darkness, silence, and the occasional rogue comet flung out by Jupiter's gravitational bullying. It was simple. It was clean. It was organized. It was completely, utterly false. Every diagram you've ever seen shows the same thing. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, all lined up like grooves on a vinyl record, spinning around the sun in perfect synchronized harmony. Everything moves in the same direction. Everything stays in the same plane. Predictable, flat, safe. So naturally, the regions perpendicular to that plane, what we casually call above and below, should be barren, empty space where nothing happens. Right? Then, in 2012, something changed everything. Voyager 1, humanity's most distant ambassador, crossed a threshold no human-made object had ever touched. 11 billion miles from home. Suddenly, plasma density spiked 40 times higher. The solar wind that had been screaming past the spacecraft for 35 years just vanished. Cosmic radiation, the deadly stuff the sun normally shields us from, came flooding in from all directions. Voyager had pierced a heliopause, the boundary where the sun's protective influence finally surrenders to the void. But here's the part that made scientists go pale. The heliopause wasn't where the models predicted, and the shape? Completely, horrifyingly wrong. For decades, we assumed the heliosphere, that bubble of solar wind cocooning our entire solar system, looked like a comet, rounded and bulbous at the front where we're plowing through space, stretched into a long, elegant tail behind us. That's what the physics said. That's what the simulation showed. That's what made sense. In 2020, researchers rebuilt the entire model from scratch, using data beamed back from Voyager, IBEX, and Cassini. When the new shape emerged from the calculations, jaws dropped. The heliosphere isn't comet-shaped. It's warped into a crescent, a deflated, twisted crescent. The protective magnetic bubble surrounding our entire solar system, the shield keeping us alive by deflecting galactic cosmic rays, is squeezed and distorted by forces from interstellar space that we never accounted for. Magnetic pressures we measured wrong. Interactions we missed entirely. Think about what that means. The boundary of our solar system isn't symmetrical. It isn't predictable. It changes shape depending on where you cross it. Voyager 1 and Voyager 2 punched through at nearly the same distance, 121 and 119 astronomical units respectively, but from different angles, different plasma densities, different magnetic field strengths. The edge itself is unstable, shifting, alive. So when we talk about what's above or below the solar system, we're talking about regions where the sun's influence bends and warps in ways we fundamentally misunderstood. We thought we knew where the edge was. We were measuring the wrong thing the entire time. But the heliopause, that's just the first layer. Because surrounding everything, the sun, the planets, that twisted magnetic boundary, all of it, is something far larger and infinitely more mysterious. The Oort Cloud, a spherical shell of trillions upon trillions of icy objects. It starts around 2,000 astronomical units from the sun and extends outward to maybe 100,000 astronomical units. That's halfway to the nearest star. It exists above the ecliptic plane, below it, in every direction, a perfect sphere of frozen debris wrapping around everything we call home. And here's the terrifying part. We've never actually seen it. Not one single object. Not directly. Every telescope humanity has ever built, Hubble, Webb, the most sophisticated ground observatories on Earth, cannot detect a single Oort Cloud object unless it falls toward the sun and lights up as a comet. But we know with absolute certainty it's there, because comets keep arriving. Long-period comets with orbits lasting thousands of years, plunging toward the inner solar system from every conceivable angle. Above us, below us, tilted at orientations that should be impossible. Something out there, something we cannot see, is continuously sending them inward. And in 2024, new models revealed something that changes the entire game. The Oort Cloud might not be a simple uniform shell. It might have internal structure, density variations, regions that have been sculpted over billions of years by gravitational tides from the Milky Way itself. The galaxy is actively pulling and warping the cloud, occasionally dislodging objects and hurling them toward the inner solar system on catastrophic collision courses. Let that sink in. The Oort Cloud surrounds us, encloses us, defines the true boundary of our solar system, and it's being organized by forces vastly larger than the sun. The Milky Way is sculpting the edge of our cosmic neighborhood, which means the solar system isn't an isolated island floating in a void. It's embedded in something incomprehensibly bigger. We're a tiny bubble inside a galactic ocean, subject to current and tides we're only beginning to understand. Now, here's where your brain starts to break. The ecliptic plane, that flat disk where all the planets orbit, is tilted 60 degrees from the galactic plane. 60 degrees. That means when you travel straight up from Earth's North Pole, perpendicular to the plane of the solar system, you're not heading into empty space. You're not escaping into some pristine void. You're plowing directly through the densest part of the Milky Way's disk. Billions of stars, nebulae, molecular clouds, cosmic radiation, magnetic fields threading through unimaginable distances. The constellation Draco hangs directly above the solar system's north pole. Polaris, the North Star, is nearby, but they're not special. They're not cosmically significant. They just happen to be in that direction because the solar system's orientation is entirely random, determined by the rotation of a collapsing gas cloud 4.6 billion years ago. If that primordial cloud had been spinning even slightly differently, above would point somewhere completely different. Different stars, different constellations, different structures. Direction has no inherent meaning. Above and below are human concepts, local concepts. They only work on Earth because gravity gives us a reference frame, a sense of orientation. But in space, they don't exist. Every solar system has its own definition of above. Every galaxy has its own plane. Every cluster aligns differently. There is no universal up or down. There's just arbitrary directions defined by how things happen to be rotating. We thought understanding what lies above and below our solar system meant mapping empty space. Instead, we found layers upon layers of structure. The heliosphere, warped and asymmetric, shaped by forces we're still measuring. The Oort Cloud, spherical and invisible, sculpted by the galaxy itself. Interstellar space, filled with hydrogen clouds, cosmic rays, and magnetic fields. The Milky Way's disk, tilted 60 degrees from our frame of reference. And beyond that, the local bubble, the local group, the supergalactic plane. Each layer redefines what above and below even mean. Voyager 1 won't reach the inner edge of the Oort Cloud for another 300 years. It will take 30,000 years to pass completely through it. 30,000 years crossing a region we cannot see, filled with objects we've never observed, shaped by forces we're only beginning to comprehend. And during that entire journey, it will still technically be inside the solar system. Because the solar system doesn't end where the planets stop. It doesn't end at the heliopause. It ends at the outer edge of the Oort Cloud, where the sun's gravitational grip finally loses its battle with the Milky Way's influence. That boundary sits somewhere between 100,000 and 200,000 astronomical units from the sun, 1 to 3 light years away. And we have absolutely no way to observe it. No spacecraft will reach it in our lifetimes. No telescope can image it directly. The true edge of our solar system is functionally invisible.
But what lies beyond that edge? Other solar systems with their own Oort clouds, potentially overlapping with ours in some chaotic gravitational dance? Interstellar clouds of gas and dust, the galaxy's magnetic field threading through everything like invisible scaffolding. We exist inside overlapping spheres of influence, nested structures where boundaries shift and blur. There is no clean edge. There is no empty space above or below. There's just more structure, more complexity, more forces we're only starting to measure. So, what actually is above and below our solar system? The answer keeps changing. Every time we think we finally define the boundary, we discover another layer we missed. Every time we assume a direction is empty, we find it's packed with phenomena we never predicted. The heliosphere is the wrong shape. The Oort cloud is everywhere and nowhere. The galaxy's pulling on us in ways we never accounted for. And the concept of above and below, the directions we use to organize our mental model of reality, don't actually exist beyond Earth's surface. We thought the question was simple. We thought the answer was nothing. Instead, we found that our solar system doesn't have edges. It has gradients, transition zones, regions where one influence gradually surrenders to another. And the directions we point to find them? They're as arbitrary as the spin of a collapsing gas cloud 4.6 billion years ago. The solar system isn't a flat disk floating in an empty void. It's a nested set of invisible spheres embedded in a galaxy, shaped by forces operating on scales so vast we can barely measure them, let alone comprehend them. So what's above and below us? Everything we never expected. Everything that shouldn't be there. Everything that proves we still don't understand where we actually are.